Hello everyone, welcome to Engineering and Economy. Today we are going to look at shading issue in solar panels. So as we know, shading issue is one of the major issue which reduces the total energy production from solar panels. So first thing we have to note that what is mean by shading. So in this picture you can see that how the tree branch is shaded on the panel. So if you look at more pictures, you can simply search in the Google and you can see how different shading issues occurs. So if you look at here, that three panels all get shaded by a tree, and here it's shaded by probably another building. So as another building is hiding the solar radiation falling on the panel, and here again a tree shading because of the tree. Here if you look at here, it's shading because of the appliances on the rooftop. It's probably that the hook appliances. Then if you go deeper into that, we can have in the next slides. So what is mean by shading? So shading means like shading a solar cell is similar to introducing a clog in a pipe, water pipe. So it means like you are blocking the water flow. You can imagine by shading what impact coming to solar panels is similar to the blocking of water flow in the middle of somewhere. So it's a similar scenario. To deeply understand this shading issue, we have to you may have to watch the previous videos regarding the series and parallel combinations of connections, and also another video regarding the how solar cells are connected in the solar module. So these two fundamentals is needed to understand the shading issue and its impact. So now, because of the shading issue, our current flow will be disrupted. So current will be reduced. Definitely current will be reduced. So in a string connection, when we call string, it means the series of connections. So two scenario. Okay, let us discuss deeply two scenarios. One is shading of a single cell in a solar module. That has one particular impact. Another impact is shading of entire one solar module in a solar system. So we have, let's say, 10 modules in your rooftop. Only one module got shaded by the disturbances or tree branches. So that is different aspects. So anyway, the shading has both shading going to reduce your solar production, but we will deal these two scenario in different things. If one particular cell shaded in a module, what will happen? As we learned previously, all the cells, if we have 36 cells, all the cells are connected in series and to get the output from the solar module. So let's say one particular cell is shaded, completely shaded. It means the current flow will be stopped, fully stopped, and we will not get any current out of this particular module. Okay. So whenever solar cell or panel does not receive sunlight due to shading or nearby obstructions, the entire installation generates less overall solar power. This is a solar PV shading. You can easily, if you watch the previous video, we talk about how each cells are connected in series. Now, if one cell is blocked, what will happen? We will not get any current. So we are blocking, we are cutting the wire in the middle. You can imagine like that. So we are blocking the current flow. Like earlier example, the water pipe, we are blocking the water flow in the middle of somewhere, then you can't receive the water at the end. That's simple scenario. So what are the reasons for shading? Like nearby objects, buildings, trees, antennas, poles. So these are the things. So when you install the solar panels, you have to take care about all the things. People may think like we are not shading entire panel, only little bit of area is shaded. But you have to understand that if you shade one single cell, then entire panel will not work. Simple. I mean, if you shade a 1 inch square uh, area, then it means you are shading one cell. That means your entire panel will not work. So many people do not know this fact, like shading of small area will have a huge impact on the entire system. So self shading is another phenomena, like because of your panel, because of your mounting of rack and all sort of things. These are all the miss planning or installation mistakes. It's because of the installation mistakes. There can be many shading issues, like and some is a horizontal shading from the terrain, and panel orientation, soiling, different aging factors, all it's create the shading. We call generally shading means if a panel is will not receive solar radiation, that's definitely a shading issue. Okay, so this is one of the main issue, because we are going to lose the total energy production. It means we are going to lose the cost. You are installing the panel with a lot of investment. At the end, because of simple tree or simple tree branch shade on the panel, you are losing a lot of money. So shading is just one out of 36 cells, probably reduce the total output by 75%. Shading, partial shading, it's not complete shading. When you shade, at least little bit of current will be passing, even though when shading, the cell will not entirely not going to work. It works, but the output current will be reduced. So this means that single cell, you can imagine the size, a very small size. Single cell, shading of single cell will reduce the 75% of output from that particular module. Okay, in shading, okay, an individual solar cell has a output of 0.5 voltage. Cells are connected in series in the module to increase the voltage. That's what I said. You need to watch the previous video. We are talking about why we go for the series connection, why we go for a parallel connections. Okay, since the cells are in series, the current has to be same in each cell. That's the key. Why the shading we have a big impact? Because we need the current to be same in each cell, because it's a series connection. You can't have a different current in the series, like a pipeline. You have a water flow. The water flow is the same water is going to flow from location X to location Y. So there's no middle something added. So the same water is flowing. Likewise, in the series connection, same current going to flow. So if some of the cells is shaded, then it will reduce the current. So that's why the total output will be reduced. Shading in series connection, what will happen? The short circuit current will be reduced, and one cell module to half. Let's say shading impacted a particular module to perform half of it is a rated current. Then what happened? The entire module become half, as I said. And earlier, whatever the impact of one single cell, it will impact the entire module. Okay. The lost output power of all the unshaded cell is dissipated into a shaded cell. This is another the side effect. Okay, shading primarily going to reduce your total energy production, which means it's going to reduce your cost, your income you get by selling to the grid, because you are installing the solar panels for the business purpose. You are going to generate electricity and sell it to the grid. In Sri Lanka, it's sell it to Sri Lankan electricity board, Ceylon electricity board, but they will pay for money for you. So now the problem is, because of the shading, your energy production going to reduce. Because of energy production reducing, you are going to lose the money. That's one major impact. What is the secondary impact? Because of the shading, the nearest cells get heated, because the unshaded cell is dissipated into the shaded cell. So unshaded cell is a healthy cell. Healthy cell can able to generate the good amount of current. That current will be dissipated into the shaded cell. This is create a heating impact. That's a problem. Okay. In even worst case system level, where multiple modules are in series, to increase the system voltage to 600 to 1000 voltage, and shading one cell could affect the entire module string. So shading of one cell may affect the entire module's performance. So that's the thing. So let's look at the example here. So let's say we have a 3 module connected in series, and we have each module is rated with 100 watts, 17.5 voltage and 5.8 ampere. All three are same rating. Usually we install the same rated panels, otherwise it create a mismatch. I already explained in the previous lecture. So Now imagine the scenario, this is shaded, first module is shaded. Because of this module is shaded, it was rated as 100 watts, now become 52 watts. Because of shading, it's working, partially is working. Because it's the voltage remains same, voltage will not impact by the shading. So voltage remains same, 17.5 voltage, but the current become 3 ampere. So current become 3 ampere. So we are running the series connection. So what will happen? This 5.8 ampere will also reduce to 3 ampere. This third panel module 5.8 ampere also reduced to 3 ampere, because the same current has to run through this network. So what happen? All the output will have a 3 amperes only. So what happens? The total energy production, earlier it should be 100 plus 100 plus 100, 300 watts in a healthiest condition, unshaded condition. Now because of shading, it become 157 watts. So 300 watts when there was no shading, 157 watts when there's a shading on one module. So see that shading impact the entire system. Shading on one module, almost it half the total production, because 300 watts, half of the 300 watts, about 150 watts. So we are getting 157 watts because of the shading. So this is the reason of shading. So every PV cell in this string has to operate at the current set by the shaded cell. The thing is, as whatever the shaded cell produce the current, that is a low amount of current, that will become a set point for the every modules. So no matter, they have to run with the lowest current which can be produced by the shaded cell. That's a problem because of the series connection. Okay. In essence, every solar cell is like a link in the chain. As I said earlier, the water pipe, you can imagine simply, is a link in the chain. So shaded cell is a weakest link, reducing all the remaining cells' power availability. Okay, this explains why even partial shading can potentially have such a dramatic effect on the total power. So you can simply understand what is going on. Shading in parallel connection. So as we said, shading in series connection definitely have a big problem, but shading in parallel connection we will not have a much problem in second. So shading has an effect on current, while temperature has an effect on voltage. When there is a shade on the solar panel, it will reduce the current of the panel. Okay. So let's say you have a panel that rating of 17.5 volt and 5.8 ampere. It will produce 100 watts of power as in the previous example. Now it's shaded come over to the panel and current reduced to 3 ampere and total resulting of 52.5 watts. Okay, in parallel connection what happens? Each module, let's say you connect 3 modules in parallel. What happens? Each module operate independently, so the shading will not have a problem in parallel connection of a module. But can we connect these cells in parallel? No, we cannot connect the cells in parallel. Cells are connected in series in a module. So if one cell is shaded, definitely that entire module will be impacted. Now if you want to talk about what is the impact of one module, shaded module in a parallel connection, the impact is very minimal, because in parallel connection each modules are connected separately to the source. So then the in parallel connection, the particular module, if particular module is shaded, that module only lose the performance, other module will not be impacted. So if you have multiple solar panels, they can be connected in series or parallel. In most cases they are connected in series. Solar panels should always be wired in series if there is not shading problem. Why we say we have to wire the solar modules in series? Because as we learned earlier, the series connection increase the voltage. Okay, so if you want a particular power rating, if you have a more voltage, then the current will be reduced. Let's say if you want 120 watts, let's say you have a 30 voltage system and you have like 3 into 4 amperes enough. Okay, let's say you have a 20 voltage system, then you need a 6 amperes. So 6 amperes or 3 amperes, even if you go 50 voltage system, you have like 2 point some amperes. So what the idea here mean, if you increase the voltage in the entire solar system, the output voltage, you can reduce the current because P is equal to V into I. Simple equation. If you can increase the voltage, you can reduce the current. Why we want to reduce the current? Because if you can reduce the current, you can reduce the size of the wires, because and size of the protection system. We don't want always in power system, we don't want to deal with the high current, because high current will lead to safety issues. High current will lead to most wire size, because current capacity, we need a wire which can carry the big current carrying capacity. The high current leads to the more cost of safety appliances, breakers, everything has to be high current rated. So that's why in solar PV system we always want to keep the current rating low, but voltage has to be increased. We need to keep like 24 voltage, uh, 38 voltage likewise. So most of the solar systems are series wired, modules, everything is series. So now in this series connection we have a shading issue that will hugely impact. But of course there is a place there we have a shading issue, we can't avoid the shading issue. Then what is the solution? That's why this teaching is, the solution is go for a parallel connection. Even though parallel connection cost high, more amount of money for installation, because of a larger wire size, larger breakers, everything is a larger size, but obviously the parallel connection will reduce the impact of shading. So definitely there's one place we have a shading issue, but we have to install the solar panels. What is the solution? Is go for a parallel connection in the between the modules. So if one module not working, it will not impact the other modules. Okay. So series connections are more sensitive to shading, while parallel connections are more tolerant. So parallel connection is a solution if you have a shading issue. In series wiring, there is no significant difference between shading of one cell or shading of multiple cell. If you are talking about within one module, if you shade one cell or if we get shaded by multiple cell, is the same impact. As I said, if one cell is shaded, the entire completely shaded, then the entire panel, entire module will not work. So the output will be 0 from that particular module. Okay, that's a scenario. Okay, what is the conclusion? Okay, now today looks like a little more long video. The conclusion is shading definitely going to impact the system, because shading we can divide into two categories. Shading of one cell, one small cell in a module, that is one category. The another category, shading of entire module in a panel, solar system. Solar system, let's say 10 modules, one module will have a shading issue. Okay, so now if a single cell is completely shaded in a particular module, the particular module will not work. If it is entirely shaded, it will not work. But most of the cases, 90% of cases, like partial shading, I mean the module will work 50% of the output. Let's say the module is rated for 300 watts. When it's shaded, it becomes 150 watts. Okay, half of the output is gone. That's a scenario. Okay, so that you can't avoid. Okay, you can't avoid. Only the way is stop the shading. I mean, you need to cut the tree or remove the tree and or install a proper location where the tree branches or any shading from the nearby building happening. Okay, the second scenario we are talking about shading of entire panels. Okay, in that case, if let's say one panel, if you go for a series connection between modules, okay, let's say 5 modules, let's say you have 5 modules. If you connect all the modules in series, then if one module gets shaded, the entire module, entire output will be impacted. But if you have a parallel connection, if one module is shaded, the other module will work. Okay, but there are other techniques. This is what is fundamental. There are other techniques like using bypass diode, that to remove the shading impact to entire system, entire solar PV system. There are other techniques that we will discuss in next video. Today we clearly understand what is the shading and how the shading impact. Thank you very much. Please subscribe this channel and provide your support so that I can produce more such content. Thank you.